Students, welcome back everybody, and welcome my dear students. We are going to talk now about the third criterion or the third criteria in decision making in uncertainty, and we are done already for both of the max the optimistic, and we're done for the Laplace. Let us see now max of the min, which, what is the meaning of it? It's pessimistic, max of the min. In the pessimistic or the pessimistic, you suppose that the worst will happen, that the worst situation is going to happen. And based on this, you are acting. You act based on this. So what you will do here, let us see how I will deal with the pessimistic situation or maxmin. We call it maxmin. This time we will deal with the maxmin. How we will do that? Okay, it's very easy. The former one was max, and this we call it optimistic because you are feeling like everything will be nice, but now you are saying feeling everything will be bad. So this is max of the min, max min, and we call it pessimistic situation. Pessimistic situation, that you expect that the worst will happen. The pessimistic, which is max of the min, max of the min. And sometimes I just want you, because of the assignments and the exams, it might come to you in this figure, pessimistic, or it might come to you in this figure. Usually we get it in this figure so that the students know what is the meaning of max min. Okay, so in this situation, let me share the screen and show it to you. In this situation, look at the max min. You will choose the lowest or the minimum number of each row. Then you will choose the max of them. Let me write it on the board. We'll stop share. And we have here already the matrix. We have it already. So for max min, we'll do the following, or the pessimistic. Step one, choose the minimum, min, of each row. Choose the minimum of each row. Second step, choose the maximum of the new column, of the generated column, which you did. Generated column, COLUMN. Okay, let's see the steps. That's the meaning of these steps. What the meaning of these steps? Okay, on the first one, the minimum of the first row, or D1, the minimum of D1, the alternate one, is minus 4,000. I don't think there is less than minus 4,000. Is minus 4,000. Look at this. Is minus 4,000. Okay. The minimum of the second line. The minimum of the second line is 1,000. Look at this. 1,000, 6,000, 8,000. Which one is the minimum of them? Is 1,000. So here we go. The third is the same, 5,000 for all of them. The minimum is the maximum. So you would choose 5,000. Once you choose the minimum, now, go to the next step. This created column which you created just now, choose the maximum number of it, because it's max of the min. It's max of the min, max of the min. So you choose the max, the min. Now you have to choose the max of them. So the max of them in that case will be $5,000. Will be $5,000. The alternate D3. Then based on the pessimistic, I will choose D3 because its max of men equals $5,000. So this was now the max of the men, and how we'll choose it. Again, I'm saying we'll choose the minimum of each row. Each row will choose the minimum of each row, like here behind me, the minimum of each row. Then after that, we'll choose the maximum number which had been generated in that column. And it will be D3. The decision will be D3 because this is the max of the men. Let us see here. You can see here the max of the men, lighten the blue one here because this is after we choose the minimum of every row, we choose the maximum, which is 5,000. Okay. We'll go also for the expected value. We'll go also for the expected value, and we'll know what is the meaning of the expected value for each. And this is also will be repeated in the decision tree. Here, it will be repeated in the decision tree, but look at that. We give a probability distribution of 20%, 20%, 60%. Because you know that all the alternates must be 100%. So let us talk about the expected value. Based on the expected value criteria, we'll take it on the next video. Thank you so much. We'll take it, we'll handle this expected value on the next video. Thanks so much.